So we can see that the light is subtly drawing to a close for another day. Um, it's mid-February, so it's late winter for us in the UK, but it's sort of starting in Leopard Gecko natural habitat. It's starting to kind of get a little bit warmer. Okay, um, so the thermostat settings have been increased a little, um, and the temperatures are starting to rise at certain points of the day, even though this temperatures, they do vary. Okay. So given this enclosure, so as a result of this, Mr. Jinx is starting to slowly come out of hibernation or semi-hibernation. And this part of the tank here, which is in view now, has had a litre of water. I've just put it in a moment ago. Spray misted, okay? So it's like rainfall, like light rain. It's had a little light rain, and it's the first time it's had any sort of rain since November, okay? Can't remember exactly when, it was like early to mid-November. And that time he came out for a drink. I remember recording a video. So things are starting to pick up. The pace of life is starting to increase. Now I'm just going to flick this main light on. So we can see some of that water has trickled through the soil, obviously downwards through gravity, towards the bottom here, which is like drainage. And whilst I'm sort of talking about this, I'm going to highlight the fact that this is a very, very important part of the setup. And I have gone through this in a previous video, but I'm going to go through it again because it's appropriate. I'm just going to keep drilling away at this. It's important to have a drainage layer. If you think in the wild, if we dig into the ground, you have the top layers of soil, then you get deeper and it gets sort of a bit more difficult to dig into because of the clay. So the top layer is kind of like a hummus, sort of fluffier sort of layer, because it's like broken down leaf litter, dead insects, dead animals, plant matter, all that kind of stuff. And then as it goes deeper down, it kind of turns into more harder sort of clay type soil. And then eventually you get to sort of like the groundwater area, and an area what's known as the water table in nature. So we're basically, through this terrarium, we're trying to sort of recreate that in a way. So if you think of the soil itself, there's a whole kind of complex sort of structure to that. So I would advise against just using one type of substrate. Let's just use sand, for example, or even just soil, as in like, even if it's something like, well, we'll stick to sand, yeah. So I would go for a variety of different soils to make up that one soil, if that makes sense, yeah. So if you're recreating a biotope, then it's it's worth looking into the sort of soil structures of their natural habitat. I haven't actually looked into that myself personally. I've just kind of gone for a bit of a mix of different organic kind of sand, topsoil, vermiculite, wood chip, that sort of thing, leaf litter to make up this soil. Yeah. Um, so this may not replicate the sort of soil structure in their wild habitat because it was just something I did myself um, through having some gardening knowledge. Yeah. But the soils in a wild habitat, obviously, I couldn't tell you, but I would imagine it varies depending on the sort of area or of the region that they're from. Where it could be up in sort of elevated forest or on mud plains. They've even been found near river mudflats, leopard geckos in Pakistan. So there's a whole variety. So, in a nutshell, um, don't use one type of substrate for a ecological setup, um, because a variety of different substrates kind of mimics that variety of soil structure in the wild, even if it is in some sort of dry part in, say, the middle of the outback of Australia, there's still going to be a sort of varied soil system in place that's just adapted to the climate out there. Okay. So it's important to have a varied soil structure, which consists of drainage layer and then the sub layers above that. Yeah. So we can see here, even though I didn't water this since November, there is still some uh, moist areas here in the drainage layer which will evaporate through the soil above and interact with other soil particles, which then trigger off gases such as nitrogen, hydrogen, oxygen. There's carbon, there's phosphorus and sulfates as well, which are like salts. And they sort of all interact with each other, which make the soil kind of living and beneficial to the microorganisms and insects such as like worms and springtails and that sort of thing, microbacteria, fungi, the list goes on. Yeah, those chemical sort of reactions um, interact with the biology of the soil, which then create that, which is what's known as a biogeochemical cycle. Okay. Um, and that basically affects the life that is happening above the soil. So, for example, the plants. And for example, Mr. Jinx. Because the insects, which live, say, on top of the soil, for instance, let's use crickets as an example, they will feed off the sort of decaying matter. They'll feed off of the bugs, small bugs, which interact with the soil below. So there's like a sort of, this chain sort of interaction. Everything is all linked together. The soil, very, very important, and having a variety, a varied mix. And there isn't a right way or wrong way as to the types of soil to use, just as long as you've got a varied organic mix. That's what I would sort of advocate for, in order to create that thriving system for the plants to thrive, and then ultimately your reptile or amphibian to thrive. Okay. So yeah, drainage layer I would highly recommend, even for arid setups. This is generally an arid setup. This hasn't been watered for months. Yeah. But a drainage layer helps, as I've just explained. Okay. So I want to talk a bit about the lighting now. I've been spending months tweaking with this, and you might think, oh my goodness, what is going on here, right? But I've basically gone for a east to west light transition program using domes instead of tubes. And the reason I went for that idea was because the sun, well, it looks round, seems to be round. So the light projected from the sun is kind of like, okay, the rays are kind of like, but you know what I mean? I don't know. In a dome, the light seems to be sort of projected well. Yeah, downwards. And so there's a variety of different domes which have incandescent bulbs. So for the heat, there's UVB, there's visible, so LEDs, and they all kind of transition throughout the day. So rather than being on statically all day, say, they come on at different times. So like on this side, these are the morning lights. And then in the middle of the day, you have the stronger lights. So like the metal halide, for example, which produces a really good amount of brightness, followed by an LED at the back, which also produces a strong bright light. So they're on at the middle of the day when the sun is at its strongest, and then it gradually kind of fizzles away to this. And then this light here is a Philips Hue smart light. So there's one on this side which is the sunset one, and there's another one on that side which is the sunrise. All of these are all wired through the back and connected to smart plugs, which are connected to surge protected extension leads. Does it use a lot of electricity? It probably uses about the same, maybe a tad more than what it was before, because there was only a handful of lights. So I'm not saying that this is the best way, because, you know, for a lot of keepers, the faff of just having all these lights may be overwhelming and complicated, but it works for creating good visual effects, and the radiation through the UVB, the infrared, and the visible light. But you can still get those radiation from tube lights. But for me personally, I don't think that's as natural as, say, having the lights transition throughout the day like the sun does in the wild. But the reptile hobby is gearing towards that more in lighting, as we've recently figured out the introduction of the new Luminize products, which create that sort of effective dimming up and dimming down to kind of mimic sunrise and sunset, and that can be done with the UVB lights as well. And then with these lights, the UVB, they don't dim. A lot of them don't dim, other than just the Philips Hue and the ones that are connected to like a dimming thermostat. But other than that, they don't dim, but they switch. So throughout the day, like a sort of like a traffic light system, as the day progresses. Okay. So it was a faff to get up, and I mean, who does this? I mean, it's just how crazy nerdy I am with this. Um, so yeah, that's what I kind of spent my money on, really. Um, but it does work. So I'm hoping. Well, it'd be interesting to see the impact it has on the behaviour of Mr. Jinx throughout the year. Um, so yeah. So the strongest brightness is in the middle of the day, and the it kind of so I've used halogen bulbs. There's one that comes on at dawn, well, sunrise. So the Philips Hue comes on first. That's only an LED, so it doesn't provide UVB or um, it's just like a visible LED, which dims on in the morning. And then that's like gradually dims, so it kind of starts the graduate the duration is like an hour long to get to its full brightness, and then the sunrise light, which is a halogen, comes on, and then followed by the UVB and then the LED visible coming on at like 20 or 30-minute intervals. And then as these lights come on for the middle of the late morning, the early morning lights go off, that sort of thing. So there's like kind of been there's a lot of thought gone into like the timing, and you know, yeah, a lot of work has gone into it basically. Um, so ideally, with the lights not being on all day, I mean, if I was to have all these lights on all day, it wouldn't work for the terrarium. It wouldn't be healthy, and it would cost a fortune in electric. But they generally each of these lights are on for about 3 hours, say, yeah, and they sort of transition, yeah. Um, the middle ones might be on for a bit longer, because when the middle ones come on, these ones are still on because the light is still like transitioning, if that makes sense, yeah. And then when this one say comes on, that one will sort of still be on for a little bit, and then it'll go off. It's, you know what I mean? It's like a pattern. So yeah, it has taken months to put into practice, but it is working. And there's fans as well. Yeah. So yeah, there's a lot of domes. You may think there is a lot of wires, but they are safely wired through the back of the enclosure and plugged into smart plugs, which are operated through an app on my phone. The metal halide is controlled via this ballast, as metal halides are. I've never used a metal halide before, so this is the first time. I thought it'd be a lot more complicated than this, but it actually isn't. It's not too bad, actually. So this ballast is the 35 watt and the 50 watt. Now, metal halides are quite particular. So if I was to get a 75 watt bulb, it wouldn't work with this ballast because with this ballast, because the ballast, as I said, is 35 watt or a 50 watt. So it only works with 35 watt bulbs or 50 watt bulbs. Okay. So at the moment, I've got a 35 watt bulb in there, which still produces a good amount of brightness. But in the summer, I may switch to a 50 watt bulb, depending. See how it goes first, as it is. Okay. So that's basically the latest kind of development. So the main two topics really I wanted to cover was the soil and the importance of that, and the drainage layer, and then the lighting. That's the kind of next important thing really, um, to get those rays correct. So like the provision of infrared, UVB, UVA, visible light, okay? Because they all aid reptile well-being together. And without sunlight, there wouldn't be any life. So if there wasn't any light really, radiation, if it was just darkness, then life would be dead. And I'm going to refer to my bug hotel, which I've stored in the shed over the winter. And I checked on it for the first time today since, like, I think it was maybe November, maybe even October when I last checked. Most of the bugs have died, which isn't surprising because it's been outside in the shed through the winter. However, there's still a few bits, like a few isopods roaming around. And so I will use them as snacks to feed Mr. Jinx as he's slowly coming out of hibernation. Because what I don't want to do is overfeed after 3 months of not eating, over 3 months. So I want to kind of slowly bring his eating routine back into sync, back into shape, really, yeah? And I'm going to think about this year feeding insects which are kind of like seasonal to how they would eat in the wild. So maybe save on the locusts, say, until spring, summer. I'll have to look into when they're sort of active in the wild. But basically start off with small little bugs, so like woodlice, mealworm, the odd waxworm, and then the odd cricket. I mean, leopard geckos as adults, they don't need feeding as often as, well, maybe even once a week. So they're hardy. Obviously, when they're young and growing up, they need feeding more regularly. But as they get more robust, they don't need as much feeding. Okay, so there's a lot covered in this video, guys, and it has been a while since I've updated, but hopefully that all makes sense. And yeah, catch you later.